Hello, today our class is on construction of index numbers and we'll also discuss unweighted index numbers. Okay, uh, first we'll see what is construction of index numbers. Index numbers, okay, uh, generally while constructing the index numbers we will face some problems. Okay, we will see first what are those. Defining the purpose is a problem. Okay. Before that, I'll give some introduction about the index numbers. Okay, how to construct. Index numbers are powerful statistical devices of measuring and comparing the uh, changes in the values of different types of commodities over two different periods of time. Okay, and second is in order to fulfill this aim, it is necessary to take utmost care and precaution while constructing the indices so as to get more accurate values to facilitate further analysis and predictions. Okay, uh, and whatever the purpose, that means in order to fulfill the aim is nothing but you are choosing index numbers to uh, for some purpose. Okay, in order to fulfill that you need to take utmost care, otherwise the intended purpose may not be fulfilled, right? And third is, if the index numbers are computed improperly, they give rise to fallacious conclusions and prove to be improper devices prove to be improper devices, right? uh, this is That's why we need uh, some skill to use these index numbers properly, right? Problems in the construction of index numbers we will see now. First is defining the purpose. Okay, defining the purpose in the first and foremost problem faced while constructing the index number is to define the objective and the purpose. Okay, in clear and correct terms. That means purpose must be uh, defined loosely. Okay, any single index number is not used for all the purposes. Okay, every index number has got its own uses and purposes. Okay, hence the determination of purpose is the basic deciding factor. It's the basic deciding factor which one we need to use. Okay, as we know that a single index number does not fulfill all the requirements, right? And in the construction of an index number, the other related aspects such as the nature of data to be collected, the statistical techniques to be used, okay, the selection of commodities, the selection of base period, the selection of average, and so on are determined on the basis of purpose. Okay, and based on the purpose we need to determine all these. According to Croxton and Cowden, an index number properly designed for the purpose in hand is a most useful and powerful tool. Okay, if not properly compiled and constructed, it can be dangerous one. Okay, example, if we wish to study the cost of living of a particular class of people, we have to decide the class of people whose the index numbers, okay, is to be computed, because the consumption of pattern of the commodities differs from people to people. Okay, consumption, people may not consume same type of commodities, all the people may not consume same type of commodities, hence consumption pattern differs from people to people. Okay, commodities, in terms of commodities, okay, we need to take uh, we need to frame, we need to construct uh, different index numbers, right? If the cost of living index numbers leads to poor class of people, then the rise in the prices of luxury items will not affect, okay, will not affect the cost of living of poor then the rise in the prices of luxury items will not affect the cost of living of poor people, but will definitely affect the total expenditure of rich class of people. Okay, the objective of index numbers also influences the number and type of commodities to be taken. If the objective of constructing an index number is to study the general changes in the uh, price level in the country, the price quotations are to be obtained from the wholesale markets, and a large number of commodities should be included. Right, these are must. On the other hand, if the objective of an index number is to study the cost of living of a particular class of people, the price quotations are to be obtained from the retail shops, and the number of commodities to be included may be relatively smaller. Unless the objective of the index number is clearly defined, the data obtained may not be appropriate to compute the desired index number. Right. And the second one is selection of base period. The base period is the period of comparison for the relative changes in the level of commodities from time to time. Right. While computing index numbers for various years, the base period index number is generally taken as 100. We must remember this. The base period may be a year, a month, or a day. It can be a month, a day, a year, right? The selection of the base period primarily depends on the purpose of index number. However, we must uh, consider following some points for appropriate base period, selecting the appropriate base period, right? Base period, first one is base period chosen should be a period of normal and stable economic conditions. Okay, normal and stable conditions. For example, now you need not consider a base period that is where COVID, but this is not normal situation. COVID affected period is not a normal situation, right? Generally, the period chosen for the base should be normal and should not be affected by abnormalities. The irregular forces such as earthquakes, floods, famine, strikes, lockouts, trade cycles, and like COVID pandemic. Okay, pandemics, right, etc. If we select a particular year as a base and it is a period of economic boom, the prices of various commodities will be abnormally high. Or on the other hand, if the year is a period of depression or economic instability, the prices of commodities will be abnormally low. Thus, the index computed by taking such an abnormal year as a base, okay, may be overstated or understated. We should remember this thing. However, the selection of a normal year as a base is a difficult job. Okay, if we select a year by assuming it as a normal year, it may be normal in one respect and may be abnormal in some other respect. We must remember, we must recognize that, right? And in order to overcome this problem, it is always better to take average of 3 to 4 years as base period. Average of 3 to 4 years, because in 1 year it may be one point of in uh, one respect it may be normal and the other respect it may be abnormal. Okay, hence if you average 3 or 4 years, that will be better to consider as base year and gives accurate results, right? Since the process of averaging will balance the effect of abnormalities in the uh, considered years, right? And the second is that the base period should not be too distant from the current period. It should not be too distant from the current period. We must remember that. The base period should not be too distant from the current period, as it makes the short term comparisons irrelevant on account of change in the habits, okay, customs, tastes, and consumption patterns of the consumers. In the long term, they may change their habits as people learn. Okay, you will get exposed to the society and you will learn a lot of things from the society, and your habits may be changed, your customs may be changed, your tastes may be changed. Okay, your consumption patterns may be changed. Hence, okay, that should not be, current period should not be uh, too distant. That is, base period should not be too distant from the current period, right? If the time gap is longer between the current year and the base year, it may influence the various values of various commodities to a great extent. Apart from the commodities, okay, apart from the commodities used in the base year, may not be continued in the current year due to obsolete or outdated or non-availability of commodities, and they may be replaced by the new commodities with better quality, right? And third one is choice based period. While selecting the base period, one has to decide whether to have a fixed base or a chain base. You should, okay, you must know this. In the fixed base indices, the base or reference period will be fixed, and okay, indices for different periods are computed on the basis of prices of single base period. For instance, if in the indices for 1981, 82, 83 are computed with 1980 as the base year, the resulting indices are known as fixed base indices, right? On the other hand, the chain base indices are computed by relating each year's price to okay, that of immediately preceding year. For example, the indices of for 1981 is computed with 1980 as base. The indices for 1982 with 1981 as base. For 1983 with 1982 as the base, and so on. As compared in the to the fixed base indices, the chain indices are reflect a better pattern of the recent fluctuations in the price commodities. Okay, there is a definitely there will be a change, that is evolutionary change found in every aspect. It may not affect when okay, uh, preceding taking as a base year and current year as a okay, current year by computing with current year, that is not a big problem, right? But the indices computed on the fixed base facilities base facilitate the comparison of price of any given year with the earlier prices, right? And third one is selection of items. The next problem of computing index number is the selection of items. The selection of items depend mainly on the purpose of index numbers. While selecting commodities, one has to see that the selected items should be representative of the tastes, habits, and customs of the people for whom the index is computed. We must know this. Okay, that must, the selected item should be represent the tastes of the uh, okay, sample which we are selecting, habits and customs of the people, okay, whom we are going to compute index numbers. Further, it is necessary that the item selected should be relevant for the purpose. Example, to calculate the cost of living index numbers, okay, of lower income group or poor people, care must be taken in selecting the item which are generally used by the people belonging to that group. We can't, for example, you take, you are calculating the cost of living index numbers for the lower income group, and you are considering a luxury car. Okay, they are not using that, right? That must be used by them. That must be that must belong to that group. Okay, it is necessary to avoid those commodities which are used by middle or higher income group people. In this instance, selection of high quality commodities and luxury items, like as we have discussed, cars, are to be avoided. Okay, refrigerators, cars, LED, 8K televisions, right? And high-end scooters, right? We can't imagine that they use. A decision must be taken on the number of commodities to be included and their quantities. If a large number of items are included in a sample, okay, the index numbers will be more representative, but at the same time it involves more time and cost. Thus, the purpose of the index numbers will play a significant role in selecting the number of items. While selecting the items, the following important points must be kept in mind. One is a classification of items into relatively homogeneous subgroups. For example, you take fast moving consumer goods. food, clothing, fuel, light, housing. For example, food, cereals, rice, wheat, pulses, grams. Okay, uh, and if we take clothing, fuel, and lighting, house rent, miscellaneous. Okay, right. And B is selection of first is selection of adequate number of representative items on the basis of uh, stratified sampling technique. Okay, and third is uniformity in the quality and grades of the commodities to facilitate easy comparison. Okay, as we are not getting high quality products and low quality products at same price, we are not giving same what we call it as importance. Hence, uniformity in the quality and grade of the commodities, okay, must be considered to facilitate easy comparison, right? And fourth one is collection of data. The prices of selected commodities along with their quantities consumed in different periods from the data for the construction of an index number. Okay, and reliable data can be obtained for the purpose of constructing index numbers from regularly published quotations and periodic special reports from the merchants, producers, exporters. Okay, or other who passes the who possess the basic information needed for constructing an index number. Apart from this, the data can also be obtained from standard trade journals, newspapers, reliable and unbiased field agencies which have conducted inquiry. Right? And fifth one is a selection of an average. Since indices are specialized averages, the next problem is the selection of an appropriate average. Okay, it is necessary to decide a particular average which can be used for constructing an index number. And there are several averages such as arithmetic mean, median, mode, geometric mean, harmonic mean, which can be used to construct an index number. Though theoretically, mean and harmonic mean, which can be used to construct an index number. Okay, though theoretically, all such averages can be used. Yet in practice, a choice has to be made between arithmetic mean and geometric mean. Okay, if you are well versed in these, any one of these, you may follow the same. Median and mode are not used in the construction of index numbers as they are affected by few middle items in the series. Okay, the arithmetic mean is popularly used due to its simplicity and understandability, but the values of index is affected by the extreme terms. This is one drawback, and as well as the merit because of its simplicity. It gives greater weights to bigger items, and if there is a substantial rise in the one commodity, right? The value of mean will shoot up very significantly. Since the arithmetic mean measures only the absolute changes, it is uh, not suitable average for the computation of index numbers. Right, one um, drawback that is. From the theoretical point of view, geometric mean is considered to be the best average to compute uh, index numbers because there are some reasons. One is geometric mean gives equal weights to equal ratio of change. Geometric mean is less susceptible to major variations that rise in the values of individual items due to violent fluctuations. Index numbers constructed with the help of geometric mean are reversible, and as such, base shifting is easily possible when we use geometric mean, right? And sixth one is selection of weights. The next problem in the construction of index numbers is selection of appropriate weights. The weights should be relevant and timely and free from bias. According to John I. Griffin, weighing, okay, is designed to give component series an importance in proper relation to their real significance. Okay, that means weights refers to the relative importance of different types of term items in the construction of index numbers. Okay, in this regard, the weights may be average quantities or prices of base year or current year, are the average quantities of price of several years and hypothetical quantities or prices, etc. While selecting the weights, 2 points to be kept in mind. Okay, that is one is the method of selecting the weights must be on the basis of the purpose of index numbers, as the chance in weights will also change the value of index numbers. And the second is selection of appropriates, which involves less computational work and permits precise interpretation. Okay. Um, Weighting system can be classified into two categories, namely one is implicit weights and the second is explicit weights. First, we will see implicit weights. What is implicit weights? By implicit weights, we mean the weights that are not explicitly assigned to any commodity, but the commodity to which greater importance is attached will represent a number of times. Okay. In this method, weights are not apparent, but items are implicitly weighted. Okay, weighted. Example: if an index number rice is to receive 4 weights and wheat 2 weights, then 4 times of rice and 2 times of wheat are to be included. That is right. Okay. In India, the Bombay wholesale prices are computed by adopting implicit weights only, right? Mm. And explicit weights. In the case of explicit weights, some outward evidence of importance of the various items in the index is given. The weights are explicitly assigned to commodities. Only one variety of commodity is included in the construction of index numbers by getting the product of price relative and the assigned weights. These weights are decided on some logical basis. For example, if wheat and rice are weighted in accordance with their value of net output, that is 80, for example 8 is 2, then wheat would get the weightage of 8 and the rice is 2. Like the explicit weights uh, weights include items like one is the weights can be in terms of production figures, okay, consumption figures, distribution figures, which are used to identify the economic importance of the commodities involved in the construction of an index number. Okay, second is these can be quantitative weights and value weights. Quantity weights are represented by small q, imply the quantity of commodities produced, distributed, or consumed in a period of time. Value weight is the product of price and quantity produced, distributed, or consumed, which can be represented with PQ. Generally, the weights may be fixed weights or fluctuating weights. In the case of fixed weights, the weights are fixed and they do not reflect the fluctuations in the relative importance of commodities. On the other hand, the fluctuating weights will take into account the changes in the relative importance of the commodities from time to time. And okay, seventh one is selection of an appropriate index number is the selection of an appropriate formula. Okay, uh, selection of appropriate formula, this is seventh. The final problem of constructing an index number, okay, is the selection of an appropriate formula. There are more than 100 formulated which have been suggested to compute index numbers. These different formula usually produce different results when applied to the same data. Therefore, there is a necessary to select an appropriate formula. A formula is said to be appropriate. Okay, if it is if it satisfies the mathematical test suggested by some theoretical statisticians. Among these tests, the most important are time reversal and factor reversals, tests which are suggested by uh, circular test, time and factor reversal tests are suggested by Irving Fisher, right? Some people also consider a circle test also. The choice of an appropriate index number formula would depend upon not only on the purpose of index number but also on the availability of the data. Okay. Mm, right, and of index number formula, none is regarded as the best under all circumstances. Therefore, on the basis of the knowledge of the different formulae, an investigator has to choose the appropriate formula for the construction of an index number. We'll see the introduction of unweighted index numbers. Okay, unweighted index numbers. Uh, the method of constructing an index number can be classified into two broad categories. One is unweighted indices and weighted indices. While constructing unweighted indices, weights are not assigned to the commodities, but the prices of the commodities alone are taken into account. And uh, to construct the weighted index numbers, not only the prices of commodities, okay, prices of commodities are taken into account, but their quantities, okay, that is weights are also considered in construction of unweighted indices. We will see now. The unweighted indices can be computed by using two methods. One is a simple aggregative method, and the other is a simple average of relative method. First, we will see simple aggregative method. Uh, this is the one of the simplest methods of constructing price indices. According to this method, the current year's aggregate prices are expressed as percentage of aggregate prices in the base year. Okay, procedure is that in order to construct a simple aggregative price index, first step is add the prices of various commodities in the current year. Second is add the prices of various commodities in the base year, and divide the total of current year prices by the total of base year prices and multiply the quotient by 100. The resulting value is the simple aggregative prices. That's all. Okay. For example, the price index can be obtained with the help of a formula that is given in the PPT. You can go through it. P01 is equal to sigma summation. Sigma is your not standard deviation, that is summation symbol. Summation of P1, that is current year prices. The sum of the current year prices, it's nothing but by sum of the base year prices into 100, where P01 is the price index of per current year on the basis of base year. Sigma P1, that is summation of P1, is nothing but total current year prices of various commodities, and sigma P0 is nothing but total of base year prices of various commodities. Okay. For better understanding, we will consider one problem here. I will do one problem. That is information given is for commodities of ABCD and prices in 1980 and in 1983 is given in rupees, and asked to construct a price index for 1983, taking 1980 as the base year. Right here we have different commodities A, B, C, D, E, and prices in the 1980 60 40 90 100 30. In the year prices are 1983 prices are 80 50 100 and 110 40. If you sum up the prices of 1980, that will be sigma P0, because if we are considering it as base year, we will represent the same with P0. The sum of these prices are 320, whereas the sum of the prices in the 1983 are 380. Hence, if we substitute, as we know this, we need to substitute the same in the formula. Substituting in the formula, P01 is equal to 380 by 320 into 100. 380 by 320, the value is 1.1875 into 100, 118.75. Hence, the price index for 1983 is 118.75. Okay, and we will take another problem. Commodities. The compute the price index for 1983 and 1980, taking 1976 as the base year from the data given below. He has given you. If you look at the PPT, you will come to know that is he has given years, that is 1976, 1980, 1983, and rice commodities are rice, wheat, sugar, dal, oil, others has given. in the year 1976, we are considering it as base year, hence which can be represented with P0. Prices in the 1980 we have taken as current year when we consider for base year 1976, right? And first we will calculate for 1980 and next 1983. The values are given. First you sum up these uh, prices of 1976, that will be sigma P0 260, sigma P1 if you sum up the okay value prices in the 1980, that will be sigma P1 is equal to 370, whereas if you add all the prices in the 1983, that will be 440. Okay, price index for 1980 is equal to P01 is equal to sigma P1 by sigma P0 into 100, where we know that sigma P0 is equal to 60, sigma P1 is equal to 370. Substituting these values in the formula, P01 is equal to 370 by 260 into 100. 370 by 260 we will get 1.423 into 100, which gives us 14.3. So price index for 1983 will become 142.3. 142.3, right? And price index for 1983 is equal to P02, we call it as price index for 1980 by okay is equal to P01. We have seen that here P01 P02, hence sigma P1 by sigma P2 we write P 2 when we write into 100. P0 we know that 260, and sigma P2 440. Okay, 440 by we will take 260 into 100, that is 440 by 260 is nothing but 1.692 into 100 is equal to 169.2. Okay, price index for 1983 is 169.2, that will conclude, right? Simple aggregative method is okay, easy to follow and simple to compute the price index, but there are some limitations of simple aggregative method that are one is this method does not take account um, account the relative importance of various commodities. High priced commodities may show their influence on the lower priced commodities, as price of commodities alone are considered to be computed price index. Okay, and we'll see simple average. Second is average, simple average of relative method. Okay, this is another method of computing unweighted price index. This method is based on averaging the price relatives of individual commodities. The price relatives are obtained by expressing the price of commodities in current year as a percentage of its price in the base year. That is price relative P is equal to price in the current year P1 by price in the base year P0 into 100. The average price relative is obtained by using any one of the measure of central tendency such as arithmetic mean, median, mode, geometric mean, harmonic mean, etc. However, arithmetic mean and geometric mean are generally used to calculate these index numbers. Okay, calculation part when okay, and calculation part, that means procedure for to calculate this simple aggregated relative method. When arithmetic mean is used to average the price relatives, procedure adopted is calculate the price relatives, that P, for various commodities by using the formula P1 by P0 into 100. Obtain the total price relatives, that is sigma P. Okay, so that means add all the price relatives given. Apply the formula P01 is equal to sigma P by N, where P01 is nothing but price index for the current year on the base, okay, on the basis of base year price. Sigma P is sum of the price relatives of all the commodities and is the number of items or commodities considered. We will take one example here, that is construction of uh, price index using arithmetic mean for price relatives. That is ABCD is commodities given, price in 1980 and price in 1983 is given. Price in 1980 considered as base year, price in 1983 is considered as current year. Price relatives we need to find, that is P is equal to P1 by P0 into 100. For that is P1 is 30, P0 is 20. 30 by 20 into 100, that is 1.5 into 100 is nothing but 150. Right? In the same manner, 60 by 30 is equal to 2 into 100, 20. 60 by 40 is equal to 1.5 into 100 is equal to 150. 80 by 50 is equal to 1.6. 1.6 into 100 is equal to 160. 30 by 10 is equal to 3. 3 into 100 is equal to 300. And the sum of these values, that is price relatives, is called sigma p, which is equal to 960. P01 is equal to sigma p by n, that is here sigma p is equal to 960 and n is equal to 5. Substituting the value, the formula P01 is equal to 960 by 5 is equal to 192. Price index for 1983 will become 169. Sorry, 192. Here it is wrongly entered 162 as instead of 192. Right? And construction of price index by using arithmetic mean of price relatives is given that items edible oil, butter, biscuits and bread units are given in kgs except bread in grams. That is also same. If we consider 1000 kilograms, kilogram is nothing but 1000 grams. 400 grams are given, units are similar. Price in 1978 is P0 considered as, 1983 is considered as P1, that is current year, 78 as base year. Then he has given these values also. We need to calculate the price relatives, that is P is equal to 10 by 4 into 100 is equal to 50, 30 by 15 into 100 is equal to 200, 24 by 8 into 100 is equal to 300, and 3 by 1 is equal into 100 is equal to 300. Sigma p is equal to 1050. P01 is equal to 1050 by number of items 4, then 262.5. Price index for 1983 will be 262.5, right? And calculation of index numbers when geometric mean is used, we have a procedure for this. When geometric mean is used to average the price relatives of various commodities, the procedure adopted is calculate price relatives P for various commodities by using the formula P1 by P0 into 100. Find out log values for various price relatives. Okay, obtain the total of log values for price relatives and then divide the sum of log values of prices in this relatives by the number of items. Find the anti-log value for the quotient obtained, and the resulting value in price index is symbolically P01 is equal to anti-log of sigma log P by n. Okay, P01 we know that price index for current years on the basis of base year. Okay, price, and sigma log P is nothing but sum of log values of price relatives, and n is the number of items. We'll consider one problem for better understanding here. He has given calculate price index using geometric mean price relatives, commodities, gold, silver and copper, iron. Has given the units of measurement is 10 grams, 100 grams, 1000 grams and 1000 grams. Prices in rupees is 1980 and 83 also given, that is 300, 800, 80, 40 in 1980, 83, 1500, 2400, 180. And price relatives we need to calculate for the same. Base year is 1980 considered as base year, and in the year 1983 taken as current year. Okay, hence 1500 by 300 into 100 is equal to 500. Okay, 8 and that is 2400 into 100 is equal to 300. 100 by 80 into 100 is equal to 125. 80 by 40 into 100 is equal to 200. For these values we need to calculate log. Okay, log 500 is equal to 2.6990, log 300 is equal to 2.4771, log 125 is equal to 2.0969, log 200 is equal to 2.3010. Okay, if you add all these log values you will get sigma log p, that is equal to 9.5740. As per the formula given, P01 is equal to log of sigma log p by n, that is sigma log p is 9.5740, as we know that n is equal to 4. Substitute these values in the formula, you will get antilog of 9.5740 by 4, which is equal to antilog of 2.3935. Okay, antilog of 2.3935 value is 247.5. Then hence price index for 1983 2.475 when it is calculated by using geometric mean. So for better understanding, we will also consider one another problem, that is the following uh, construction of price index by using geometric price relatives with the given data. That is, it has also given commodities as rice, wheat, sugar, dal, oil, fuel. Prices in 1980 is considered as base year prices and 1983 as current year's prices. Prices in 1980 is given as 25, 50, 10, 40, 80, 120, and prices in 1983 are given as 45, 60, 20, 80, 100 and 150. And then price relatives we need to find out, that is P1 by P0, that is 45 by 25 into 100, that is 180, 60 by 50 by into 100 is equal to 120, 20 by 10 into 100 is equal to 100, 80 by 40 is equal into 100 is equal to 100, 100 by 80 into 100 is equal to 125, 150 by 120 into 100 is equal to 125. Now for these values, these p values, we need to consider log, find out log. Log 180 is equal to 2.2553, log 120 is equal to 2.0972, log 200 is equal to 2.3010, log 200 is equal to 2.3010, log 125 is equal to 2.0969, and in the same way same log 125 is equal to 2.0969. if you add all these things, okay, that is sigma log p is equal to 13.1303. hence p01 is equal to antilog of sigma log p by n is the formula that is given to calculate price relatives by using geometric mean. Okay, uh, that is here sigma log p is equal to, we know that 13.1303 and n is equal to 6. Substituting these values in the formula, p01 antilog is of 13.1303 by 6. Okay, and now we got 13.1303 by 6 is equal to 2.1883. For this we need to find out antilog. If you find out antilog, that will be 154.3. hence price index for 1983 is 150.3. and okay, merits of this method is the average price relative method eliminates the impact of extreme items, and okay, since all the values are given equal importance, the price relatives are pure numbers and they can also remove the effect of different units of measurement. This is one merit that we have, okay, come across when we use this geometric method. And limitation is that this method has certain limitations. Out of the several averages, selection of an appropriate average is a difficult task. This method does not give relative importance to various commodities, as all the items are treated by assigning equal weights. This is one drawback that we have studied. Okay, with this we have finished the class. Thank you.